How's it going, everybody? We're back again, and we're going to go over some stuff. We're going to do some conceptual NAT real quick. I'm going to go over how kind of NAT works and how that pretty much brings the network together. And then we'll quickly go over what ACLs are. So I'm going to bring my drawing back in here. Yes, it is the same one that I had going on earlier. But this is what we're going to talk about. NAT in its most simplest. Actually, I can, because I didn't close any of this stuff out. Haha. NAT, Network Address Translation. It was the answer to the IPv4 address shortage. As you all know, there are only 32 bits in a IPv4 address, which leaves you about 4.2 billion that you can use. Actually -2 at the most, because you have a base network and a broadcast. But NAT, Network Address Translation, it allows you to take one network range and allow all those different network range, that entire network range, whether it be 2 addresses or several 100,000 addresses, and route out one public IP. So typical NAT is going to be a private address range, the 192 network, the 172 network, the 10 network, to route out a public IP address, like the 192.169, if you're so inclined, because the 192.168.0.0 through 192.168.255.255 is the actual private IP range. So basically what we're going to do is I'm going to kind of explain NAT in a very simple format, and then follow that up with ACLs, because you need an ACL to NAT, and ACLs kind of lead into NAT. So I wanted to cover NAT real quick so you guys weren't completely blindsided by it. But NAT, like I said, if you have, let's say, the 10 network, and then the 10 network and the 172 network, and you have these 2 network ranges, but you only have one public IP. And this is your public IP address. So we're going to say 201.1.1. Okay, so 201.1.1.1. Let's say that's your only public IP address you have. Okay, telco gave you a single public IP address, so you had to figure out a way to get all of your, let's say you have 300 hosts here, and you decided to expand, and you've got 125 on there. So that tells me out of the gate you're going to have a /25 for this group. This is going to be a /25, and this will be a /23. Okay, just going based on hosts. So you have 425 users you need to get out to the internet, and you need to allow them to do that. Well, NAT allows you to do that over one public IP address. NAT, in its most simplest form, actually means one-to-one, meaning you can have one private IP address NATed to one public IP address. So that is NAT in its most common form. Now, that's actually static NAT. So you have one-to-one. You have static NAT with overload. So you can have a pool of addresses, and that pool of addresses is overloaded, meaning you're using, at that point, it's called port address translation, to where you're using port numbers on the router to get out to the internet. Same IP addresses, same private IP, same public IP, just different port numbers. So it's going to leave out, say, port 80 on your end, and then it's going to hit the web server on port 59,000. It's going to hit the web server on 59,000, and it's going to come back in on port 59. It's going to leave out, I believe it would be port 80. I might actually have to go back and double check on that. But we're going to actually, you know what I'll do, is I'm going to open Chrome real quick. Just going to go out to, go to YouTube. Well, actually, this will be a shameless plug, and it's not because I'm a Cisco guy, but we're gonna go to INE's website, okay? And as soon as it pulls it up, these are the guys that I use for my CCIE training. So what we're gonna do is this. Now I'm natting, so I'm gonna go CMD. This will be the best way to explain this to you guys. So we're going to do netstat-n. Oh, how about that? So, my IP address currently right now, actually, you know what, let me do one thing real quick. Okay, and as you can see, as you can see, I was actually wrong. It's the other way around. I have a established connection to INE's website. Actually, quite a few established connections. So, what these connections basically say is, on my computer, it's leaving out port number 49,542. It's hitting, well, that's 443, but it's hitting 74.125, 225, 124, port 80. As you can see, it's an established connection right here. What that means is this. It's leaving out my port number on my router, and then it's hitting, and it's a TCP connection, it's hitting their port 80, and it's leaving their IP address probably on something more like, it could be leaving on port 80, but I can't see web traffic being, well, it could be. And then coming back in on 49,545. These are random port numbers. Anything above 1,024 or 1,023, 0 through, we're going to go 1 through 1,024. Anything above 1,024 is considered, well, 0 through 1,023 are considered well-known port numbers. Anything above that is pretty much free for you to use. Well, mostly. There are like 3389 is going to be remote desktop, and 443 obviously is, secure web surfing, that type of stuff. So that's how that works. It leaves out here on a random port number. It hits this IP address on this port 443, so we know it's a secure connection. So with that being said, I'm not connected to, well, actually it's because I had Yahoo opened and some other stuff. So let's do that one more time and see if that helped. See, it's got a lot less going on here. So I have open connections to INE, and they're pulling information from their website, which might be multiple servers. They have locations in a couple different parts of the country. So they might be sending me information across the internet from 2 or 3 different web servers. So this type of stuff is where you're going to get 1.254. Wonder what that is. Oh, you know what? Do I have anything else open? No, I don't see anything. Anyway, I just wanted to show you guys that's how it works when you're doing some sort of TCP connection. You're going to have a SYN would be the first flag to hope it's synchronized. A SYN-ACK will be the response from the server, and then you'll have a SYN-ACK, and then you have an ACK. SYN-ACK, ACK. The acknowledgement is an open TCP connection. So that's what you guys need to watch out for. So with that being said, let me pull up GNS3 again. That's how that's going to work. Now, that's a TCP connection. The same thing applies with NAT. And that's actually what NAT does. Because you can have, like I said, one public IP address and multiple private IP addresses, and just to be able to get out to the internet. So, now ACLs. What's an ACL and why are they so freaking important? Access control lists, they do a lot. And actually, the farther you get into Cisco and networking as a whole with Cisco, you will find out that access control lists will become something you need to know. I have gotten to almost the same point with subnetting, or ACLs, as I am as comfortable with subnetting. I can subnet pretty quick. Lots and lots of practice. ACLs I'm right behind it. I feel pretty good about ACLs. Same thing with NAT. Now, the reason I feel like that is because every day I deal with this stuff. You know, somebody will call me and say, "Hey, can you check the NAT statements on this guy and see if it's natting?" Okay, well, I'll do a show IP NAT translations. Okay, yeah, it's natting. This is the IP address. This is the port. And I'll be like, okay, cool, it's working. Then there will also be ACLs. You'll have to figure out if a client's traffic is being caught by an ACL that's misconfigured, or whatever the case may be. So ACLs are going to be something you need to know. So I'm going to bring up GNS3. I've got router 1 open here. And we're going to do a... Let's do this. I'm going to bring this over here. And I'm going to bring up R3. Console. And I'm going to close out Chrome. And I'm going to do show IP interface brief. Okay, cool. So that's what we have there. So I'm going to bring that over to here. I'm going to slide this guy over here so you guys can see what's going on. Now this is R3, this is R1. I'm going to configure an access list on R1 outbound so that traffic from R4 cannot reach R3. Okay? And you're like, well, how are you going to do that? Well, simple. You can do it multiple ways. I'm going to start off with a simple access list. On R1, I'm going to do config t, type in IP access list. Question mark. What kind of access list do I want? I want a standard access list. Okay. Do you want to name it with a word, or do you want to give it a number? Well, for the sake of argument, we're just going to start with a number. 1. Question mark. Carriage return. What do you want to do? Do you want to deny, make it a default set of commands? Do you want to permit it? Do you want to put a remark in there? Do you want to put a no to stop it? Well, we're going to deny. Actually, that brings me to a very good thought. I just thought of this. It just hit me. This is something I need to cover. Let's see. Let's scroll down here. Oh, there's not a whole lot of room to scroll. So what we're going to do here is we're going to do rectangular, and we're going to take this whole section right here, and goodbye. We're going to go back over here to the brush. There's a few things you need to know about ACLs that are going to be like muy importante. I don't speak Spanish, but that means really, really important. What you need to know is this. You have ACEs, access control entries. These ACEs make up ACLs, access control lists. For every access list you put in, you know, let's say permit, deny, permit. If at the very bottom, down here, let's assume you've got a whole bunch of entries, and we're just going to say this. This guy right here is the catch-all deny. It's an implicit, invisible implicit deny. What that means is, as you're going through the access control entries, okay, as you're going in sequence number, because they're sequenced, it's 10, 20, 30, 40, and so on and so forth. As they get matches, that's as far as it gets processed. So if it matches a statement, like this guy gets matched, it says, okay, well, it's permitted this way, then it goes down, then it gets shipped out. If your deny statement goes farther, if it goes past, it'll go permits this, but if it's a permit on this statement here, I had to catch myself on that. If it permits it here, but it matches the deny statement, then it's done. It's not going to get forward. It's going to get discarded. So, if it doesn't match this guy, it doesn't match this guy, it goes to this guy. Does it match that one? Then it keeps going on. Or it says, well, if it matches the permit, it keeps going. If it doesn't match, it doesn't go. It just interesting. I just caught myself in a conundrum. So, but as I was saying, assuming that the the packet makes it all the way through the ACL to the very bottom, if you do not have a permit any above or before, the same thing actually, it's above or before the implicit deny, it gets denied. Doesn't matter what. If you do this and you aren't careful with the way you implement your ACLs, you can block too much, block not enough. Now, here's the other catcher. We'll say this guy right here is R4. Okay, and this guy over here is R3. Okay, this guy sends traffic this way, it comes out this way, gets routed down this guy. If you are using standard access lists, you need to put this access list as close to the destination as possible, because standard ACLs only match on source information. Okay, so if you put a R4 ACL that's a standard ACL and it's a deny here, it's not going to go anywhere. It's going to stop. So you have to put the standard ACL, because it matches on source destination, source IP, as close to the destination as possible. Inbound on the router that you don't want it to get to would be preferable. Now you're thinking to yourself, and I thought the same thing, well, isn't that kind of a waste of bandwidth? Yes, it is. ACLs are good. Standard ACLs are good for NAT because they, it's real simple. You want to match an entire range, permit it, and then do a permit all. So the other thing is about this is standard ACLs, they permit on the entire TCP IP, that's TCP and UDP protocol stack. Okay, there's no way to break it down. So it's the entire whole, I know I'm drawing that out of sequence, IP stack as a standard ACL. Okay. Extended, the EXT, you can break down based on TCP, based on UDP, based on source and destination IP address, based on port number. So you can get a lot more granular with an extended ACL. Now, the opposite of a standard ACL is an extended ACL. You need, with an extended ACL, to put those as close to the source of the traffic as possible. So with the standard, you put a standard over here on this guy, where you would put an extended access list right here. Or, if you're so inclined, on the outbound interface as an outbound ACL, because you can put one access list per interface per direction. Okay, so you can have two access lists, one inbound, one outbound, but you got to make sure your entries are not conflicting with each other. Because if you have conflicting entries, traffic's not going to go anywhere. Or it'll be matching one where it's supposed to be matching another. One will be catching too much. The other one might not be seeing it at all. You may have not enough capture, and then things are getting out where you don't want them to. That's the one thing you have to be careful of. Like I said, the extended access standard is the whole IP stack. Okay, where extended you can break down based on TCP, UDP. You can break down on source based on destination, and not TCP source and UDP destination, but source and destination TCP, source and destination UDP. Also on port number. So let's say you wanted to block TCP as the protocol, you wanted to block the source address from getting out to HTTP, port 80. You wanted that to happen. Well, you need to make sure you configure it correctly, but you wanted to permit everything else. So I'm on R1, or R3 I should say, R1. So let me pull up GNS3 again. So we're on R3. We're going to configure a standard ACL on R3. So what we're going to do is we're I've already gone too far on this guy because that's wrong. So we're gonna say no. Better turn it off. So what we're gonna do is we're gonna go to global config, type, and R4. Do I already have that open? I do. So we're gonna do show IP interface brief. I want to block the 172.20 or 0 because it's show run interface fast 0/0. Okay, it is a 128. I wanted to make sure on that. So on R3, we're going to go IP access list, and we're going to type in, we want a standard because it's standard, and question mark. We're going to give this number, just 1, and then we're going to say we're going to deny. Okay, what do we want to deny? Do you want to deny a host to match, an IP address range, or do you want to match a source or single host? Basically, this, or actually this guy, and this guy are all the same thing. It's when you get to this guy right here, to when you do a whole range. Because what we're going to do is we're going to block the 172, we're going to deny 172.20.0.0, and then we're going to match the wildcard mask. See how it says wildcard? We could just match we can block that whole range, but we don't want to do that. So 0.0.0.128, because that's what we have it configured as, is 128. Question mark. Do we want to log it? Sure, let's log it. Log. Question mark. Enter. Now, what we've done is we've denied the 172.20 network from getting to R3. So, what do we want to do now? Well, we want to apply it. Or actually, one more thing. Remember that invisible implicit deny that I was talking about a minute ago? Well, that invisible implicit deny still applies here. So right now, I'm going to show you something that why you need to put things where you need to put them. So we're going to type in end. Oh, actually, we're gonna go show access list. I need that. We have an access list. Okay, it's not configured, but we have an access list. So what we're going to do is this. We're going to go to global config mode. We're going to go do show IP interface brief, and we're going to put it on serial 0/0.301. So interface serial 0/0.301, and type in IP access group question mark, and how do you want this to look at? What do you want it to look for? Well, we want it to look for access list 1 question mark. Do you want these packets to be inbound or outbound? Well, we want to stop traffic from coming in, so we're going to type in question mark carriage return. Now, what we're going to do is this. We're going to do end, and we're going to make sure we keep that right there. So nothing's happening yet, but what we're going to do is this. We're going to ping, and what is that IP address? 172.20.0.139. 172.20.0.139. See how it says u.u.u, destination host unreachable? Well, let's hit the enter. Well, it's not showing anything, but show log. Oh, it's 26 lines logged. Show access list. Show logging buffered. Show logging history. Question mark. let's go back to config t interface 0/0/0/0. 0 is it 0/0.0? We're gonna go to 0/0.301, and the last command that I put in here was this guy. Up, see, right there. It took it a minute, but that's actually what I wanted to show you. If you don't put in a permit statement, it'll bring down the neighbor, because it's blocking too much now. Okay, so what you need to do now is, we'll see how it says log. Well, that's fine. Actually, we're going to get rid of log, and oh, I see what happened. Okay, so what we're going to do is we're going to hit Control A and type in no. Now, it should come up relatively soon. Now, it is over NBMA, so it may take it a minute, but because that denied too much, and I wanted to show you that. So, next I'm going to go end, and there it goes. It brought the neighbors back up. We're good to go. Now, that being said, I'm going to try pinging that same address again, and I can ping it. That's an access list. So, config t, type in IP access list 1, and then we're going to type in Control A, type in no. Complete command, question mark. Oh, standard 1. There. I've killed that ACL. So what I need to do now is I need to go in here, and I'll actually do the same thing. IP access list standard 1. Enter. I'm going to type in deny 172.0.0. or 20.0.0 0.0.0.128. Enter. And I also want, because it has not applied to anything, permit question mark any. So what that does is it puts show access list. I have a deny statement, deny that R4 to get to R3, and there's a permit statement afterwards. So what we're going to do is we're going to go to config t interface 0.0/0.301, type in IP access group 1 in. So show access list, and it's already showing things. So what we're going to do is we're going to ping that's not working out the way I wanted it to. Supposed to be not denying that. That's not cool. Supposed to be denying that range. Oh, wait a minute. That's my fault. The reason it worked the first time is because of the fact that it was pinging from. Actually, let's do this. That's my fault. R5, and I'll explain here just real quick why it's doing that. Ping 172.0 or 20.0.139. It's doing it for that too. That's not cool. Oh, you know what? I think I know where I goofed. Because I've got a 128 in here. I think I need to put a 127. Because I think it's confusing it. So, let's see here. IP access list. Standard 1. And type in, let's see here. Control A no. and then just hit the up arrow once, a couple times, and take this off and put a 127 and do that. Now do show access list dash list. There it goes. Oh, you know what? See, that's what happens when you do things stupidly. Control A, deny, or no. Do the same thing here. Control A, type in 10. Put a sequence number in front of it. And same command here, 10. Let's try it now. Oh, there we go. That's more like it. Because I was giving it a 127, it wasn't working. There, it's more like it. See, yeah, everybody makes mistakes. That's where practicing this stuff comes in handy. Because basically, what you're gonna 127 is going to be 0 through 126 is what it's going to deny. 128 actually is the next range, so it'll be the 192 range. So as you can see, it's 11 matches. I'm going to do it again on here. Hit enter, and then I'm getting denies, as you can see. So destination host unreachable because of the fact that it's being denied by an ACL. Now I'm going to do the same thing, except for on here I'm going to type in let's see here. We're going to go do the same range, except for I'm going to go Control A, type in 05. Actually, no, I take that back. I'm going to type in, let's see here, Control U, interface 00/0.301, and then, let's see here. There we go. Control A, no. So that does that, and then I'm going to type in, let's see here. Control A, no IP access. There we go. So we're going to go a little more granular. We're going to configure an extended access list, but on R1. Well, actually, no, we're going to go on R4 because we want R5 to be the guy to block it. So R4. So then you're asking, well, why was it doing that? Because when you are doing it from R4, it's pinging from the serial interface, not the fast Ethernet. So when you ping, you need to ping from a source of fast 0/0. It's going to work because I took the ACL off, but if you were to ping, because you see now you're pinging from 1 instead of pinging from .169 or 170. So you're blocking from a different range. So that's where that comes into play. So on R4, so we're gonna go config T, and we're gonna type in IP access list. We'll type in extended, type in 1. Well, actually, valid number. Question mark 100 through 199. We're in 100. Question mark. Enter. Type in deny. Question mark. What do you want to deny? Well, we're going to deny pings. We're going to deny ICMP. Question mark. What's the source address? 172.20.0.0.139. Question mark. Source wildcard bits 0.0.0. What's that? It's 7 because it's 7. Question mark. Destination address. Oh, my bad. Source address is 0.0.0.127 because you want to block R5 from getting to R3. So from here to here. So, and the question mark is what's the destination address? 172.20.0.139. And then the wildcard bits 127 172.20.0. Or my bad, 0.0.0.7 question mark. And what do you want to block? We're going to block echo, as you can see right here. Echo reply, that's pings. And as you can see, it says ping right there. So we're going to type in ping echo question mark. Actually, is it EQ? EQ doesn't recognize that one. Echo. Yes, that is exactly what I want. Now, let me read this to you. I want to deny ICMP. I want to deny ping and trace route from 172.20. I hate when I do that. Let's minimize that. Bring this guy down here. Actually, let's get rid of R1 and get rid of R3 for the time being. So, in English, this is saying, I want to deny the ICMP protocol, ping and telnet, or ping and trace route. I want to prevent the subnet 172.20.0.0 with a wildcard mask of 0.0.0.127. So I want to block this entire range over here, the 126 users, from being able to reach the destination of 172.20.0.139. And with this .7 is the thing, as it gives us /29 of R3, R3's destination IP, and echo. Enter. I want to permit question mark. You want to permit everything else, or do you want to permit specific other things? Well, for this case, we're going to permit everything. So IP, because that's TCP, UDP, ICMP, and anything else that's out there. So IP, and then we want any source, question mark, to any destination. So I permit IP any. Does that make sense? Enter. Now what we're going to do is we're going to type in end show IP interface brief, and we're going to go under, or we're on R4, so we're going to go under the, as close to the serial interface as we can to the source. So under Ethernet. That was kind of slow. Under the fast Ethernet. So config T, interface fast 0/0. Type in IP access group question mark. What access list do you want to put under here? 100 question mark. And this is where you got to be careful. Anything coming inbound would be in. Anything going outbound would be outbound. So we're going to type in. Enter. That's it. So now we're going to pull up R5. And we're going to try to ping this guy. It's kind of funny how every time I try to ping something, it doesn't work, huh? Show access dash lists. Notice how all other matches are getting through, but echo replies are not. Kind of funny, huh? Now, oh, you know what? I denied that entire range. So let's ping 192.168.1.1. I can ping that, because actually I deny too much. I deny that entire range, because I won't be able to ping 138 either. Yeah, it's deny. I only wanted to deny one, but I denied too much, and it sees that. So actually what I can do is on R4, I can modify that a little bit. Config T, IP access list. Oh, you know what? Control U and config t IP access list 100 extended 100, type in, do the up arrow a couple times to get to my line here, Control A, no, enter, type in 10, deny ICMP 172.20.0.0 0.0.0.127 from 172.20.0.139 0.0.0.0 echo. And enter. Now, if you notice, I put the 10 in front of it, so it's going to be do show access dash list. And as you can see, it's right there. So we're going to try to ping 138 again. Or, I'm sorry, 139. I blocked 139. 139. And it's getting denied. But I can ping 138. That works. What about ping 137? Why is that not going through? Interesting. A lot of matches for that. Permit IP any. Why is it? Can't I ping that one? That's just weird. I see it in the routing table. Config T router OSPF 1 no auto. Oh. Question mark auto cost. How do I not summarize? Auto summarization. No summary. There we go, no summary address. 172.20.0.0 0.0.0.255. Thought that was the no auto summary. No summary. Oh, well. Oh, there we go. Show IP route. Ping 172.20.0.137. That's better. Sometimes it just, it's GNS3, sometimes it just goofs up. Oh wow, I've been talking for 44 minutes. Well, I'm going to cut this video short. That's access lists. I wanted to show you guys how that worked. And that was kind of a major thing. I just wanted to show you guys how it all worked. And as you can see, the pings, or the deny pings are working. Everything else is getting through. So I'm going to cut this video short, and then that's access list. The only thing left to do until this video series is complete is actually, I'll adjust my headset here, is actually just I have adjacency issues. Don't ask me what's going on with that. You know what, it might be it couldn't be the access list because it's not denying that much. So anyway, Um, that's the only thing that. Well, anyway, that's access lists. If you have any more questions about ACLs, hit me up. They're not hard to figure out how to do. It's just a matter of configuring them correctly. And then I will do a NAT video, and that NAT video will cover everything we need to do. So I'll do static NAT. I'll do a range of NAT addresses till they're overloaded, and then I will also do dynamic NAT, which is a range to a range. So I hope this has been informative for you, and I would like to thank you for viewing.